Morning, guys. Welcome. Today is members meeting day again. You guys have all logged into the AREP members meeting, and today I think is the 5th of July, 5th of June. We are going to give the other guys a couple of minutes just to sign in. So welcome. It's going to be an interesting session. Today we're going to be taking a look at some mounting structure and the lighting and surge protection on the mounting structure. I was on a site yesterday. I looked at the site and decided that it would be an apt or an opportune time to quickly have a look at bonding, surge protection, and lightning protection. We are going to be covering a couple of principles on that. We are just giving the other guys a couple of minutes to log in. Our guest speaker, as far as the lightning and surge protection is concerned, is going to be Kenneth Roets. What else? You will notice that I've got a camera in the camera. That's because I've had some technology challenges which I couldn't solve. I would have wanted to be able to zoom in on my iPhone the way I normally do, but for some reason today my technology has not allowed me to do that. So I've kind of just made a quick plan to change it. Maybe while we're waiting, so for those of you that have just logged in, we haven't officially started, but maybe while you are waiting for the other guys, I had this on the board before the meeting started, and I think maybe we should have a discussion about this in next month's meeting. So there was an installation I went through to have a look at, and at the site, the guys had a load previously of 15 to 20 kilowatts. Their power factor was 50 kVA, which mathematically means that the reactive power has to be 50 kVA as well. When they had their solar system installed, what effectively happened was the active or the real load reduced to 5 kilowatts because of the solar that was installed, but the power factor stayed 50 kVA, and the kVAR or the active power stayed 50 kVA as well. So this is interesting. If you are going to get involved in commercial installations and your customer has a demand charge on their bills, it's possible that your customer is not going to see the savings that they're expecting because of the reactive power component in the electrical bill. So I think maybe for the next, I was kind of tied between what do we do next month? Do we do net present value and internal rate of return, or do we do solar economics and a discussion on accounting for solar proposals, which would be before you submit the proposal? Do we have a look at what the response is on your electrical network post the installation? So this is kind of both interesting discussions. The one you would use to promote sales, the other one you would use as an after sales function to make sure that your customer is getting the savings that you committed to or promised them or that they're expecting. Guys, good morning and welcome. My name is Carel Ballack. I'm president for AREP. Today is the 5th of June, and I think I have to officially start the meeting. For those of you that logged in previously, for those of you that have logged in a little bit earlier, we had a look at what we might be discussing next month, which would either be power factor or solar PV economics and accounting, kind of looking at the net present value and internal rate of return for solar PV systems. Today's discussion, however, is going to be covering something completely different. We're going to be looking at lightning and surge protection, as well as bonding. And do I want to say air termination? Yeah, I think air termination, because it's air termination that started it. I was on a site yesterday. These guys had air termination rods all over the installation, but none of them were connected. It was an amazing install, beautifully done. They even had the bolts marked where they torqued the bolts. They had little permanent Koki lines over them to show where the line of the bolt was. So it was an impeccable installation, except for a couple of questions I had around surge protection, lightning protection, bonding, earthing, and that kind of thing. And that prompted me to have this discussion today. So that is something that's going to be held between myself and Kenneth. If you guys have questions around it, we will have a Q&A session as well. Guys, quick question. We do have an AREP WhatsApp group, and the topic was shared on the AREP WhatsApp group this morning. So if you are not on the AREP WhatsApp group, there might be value in it for you to join the AREP WhatsApp group, because then at least you can get updates on what is being discussed and who it's going to be with. And yeah, that's it. So I'm going to wipe the board, and then we can jump right into the meeting. Mariasha, are you more or less ready?
Yes, 100%. Okay, so I've just put the WhatsApp group's QR code on the screen. So when Carel mentioned the WhatsApp group, you can just scan the QR code. I'm going to leave it up there for a little while so that everyone can just maybe scan it if you haven't scanned it already. Otherwise, you can also just reach out to myself or Jocelyn, and then we can send you the link. So before we get to the very interesting part of this conversation, which is what Carel covered just now, I just wanted to give you a brief update on where AREP is as an organization. We're happy to report that the organization has been steadily growing for the past few years. So if you have a look at the membership statistics, we have finally reached 5,000 members. So when we say how many members we have in a conversation, I can officially say 5,000 without exaggerating, and that makes me very happy. So we have 5,000 members, and that's wonderful news. We have 123 company members, 22 founding members. These two types of memberships means that you have committed some financial backing for AREP. It's really not expensive. The company membership is 2,500 for the entire year. And then you get lots of benefits of that. So you get exposure on our website, and you get additional marketing bits and pieces, and you also get an opportunity to address members, things like that. So the company and founding members have just committed financially to supporting the association, as well as submitting to the Constitution and the Code of Conduct and everything else that the free membership has. And then we have had 244 P4 tests written in 2025, which we feel is a little bit low. And a little bit concerningly low, actually. I just want to try and mute these. There we go. So I'm trying to mute. Hold on.
Yeah, maybe it's because we both trying
Bar,
to.
can you just mute your mic, please? Because there's some noise coming through. Thank you. That's brilliant. Okay. So we see that the P4 tests in 2024 have been a little bit low. So we've seen a lot of guys allowing their accreditation to lapse or not progressing to level 2. So we wanted to encourage the industry to really just keep your knowledge up to date and to keep your accreditation up to date as well. We do review the test questions every now and then. We actually just had a session reviewing level 2 this week, which I was very thankful for, that we got to just spend some time looking at the questions and investing in updating the test and clarifying some of the questions. So the likelihood that you ever write the same P4 test is very, very low because we update it every year. So in level, I wanted to show you these statistics. Our level 1 practitioners, we have 1,100 guys that has allowed their accreditation to expire. And we only have 280 people whose accreditation is up to date. So if you are one of those 280 people, congratulations and thank you for keeping your accreditation up to date and making sure that you provide the best knowledge and service to your clients. If you're one of the 1,100, please reach out to us. We want to make it easier for you to get accredited and keep that accreditation. You can renew your level 1 this month at only $650, so that means you save $300, or you can advance from level 1 directly to level 2 and write that test for only $950, which means you save $400. So yeah, let's just take our profession serious, as we all do, and make sure we keep our accreditations in check. Then I did show you guys this slide. I just wanted to make sure that you know where you can find us or where you can reach us if you need some information. You can keep an eye on all of these channels because we post articles or some information bits, or whenever we're having an industry meeting, we share the details of the meeting on those platforms. YouTube, if you want to subscribe there, we always post the recordings of any public sessions that we have. We post on the YouTube channel. And then I would say LinkedIn is probably the one that's most up to date. We connect with a lot of guys on LinkedIn. And then obviously the WhatsApp members group as well. It's not a spam group and it's not a group where all of the members can send messages. So the only parties that can send a message on our WhatsApp group is AREP members itself, is AREP team members, I mean. So it's only the administration. So you're not going to get a bunch of spam. It's really just a tool to keep industry updated on what's happening. Okay, great. That's it from my side. Finally, we get to the interesting stuff. Carl, you and Kenneth can go ahead and blow our brains.
Okay, thanks, Mariesha. Good morning, guys. Sean Carel says, what about level 3? Wow. Okay. Yeah.
Good point.
So I did have someone. I just want to pin my video. I think if I pin my video, I'm going to be my entire screen. So we did have a conversation with someone earlier this week who said that there might be value in stepping up the accreditation to include commercial installations as well. So you guys will notice that for those of you who didn't sign in early, I've had some technical challenges this morning, which is why I've got two kind of cameras in view, the one that I'm on and the one right next to me. So the idea was to be able to just switch cameras, because for some reason I couldn't get my camera to zoom in on the screen. And now it looks like it's in reverse. Is it in reverse, or do you guys see this correctly?
We see it correctly. I think you're
correctly.
Yeah, we see it correctly.
Yeah, it's in reverse on my laptop, but it's fine. I don't need to be able to read it there. I just need to be able to read it here. Okay, guys, quick thing. So Sean, we do have a level 3. The level 3 is a level that is kind of a peer review. So So level 1 at the moment covers solar principles. Level 2 covers solar and electrical principles. Level 3 is a physical inspection of your site. So it's a physical inspection, and we are considering making level 4 commercial and industrial installations. So where level 1 covered solar principles, level 2 covered solar and electrical principles, level 3 physical inspection, level 4 commercial and industrial. This is probably going to start covering power quality, things like harmonics, power factor, and solar PV accounting, and slightly higher level calculations on HV batteries, bigger types of systems, bigger cables, more current, more power management, energy management, and that kind of thing. So it's exciting to see the platform grow. But that's just to quickly cover Sean's. That's just to quickly cover Sean's question. Sean, I see you posted another question. I'm going to stick to the agenda, and then we can cover your questions in the section at the end of the meeting. Yeah, I hear what you're saying. Let's get back to the agenda. Guys, I'm not sure whether I've introduced myself as part of the formal opening of the discussion. I know I did before we started the meeting. My name is Carel Ballack. I'm president for AREP. And we are going to have a couple of interesting discussions today. Mariusha, have you got the... I think the next item on the list was to have an actual discussion with Kenneth. Is Kenneth in the meeting?
I did see him.
There you go.
Let me just...
Yes, I'm there.
Okay,
Good
cool,
morning.
Kenneth. That's great. What we can do is, Mariusha, could you make Kenneth co-host so his name pops into the top of the screen, then it's easy to find him.
Okay.
Guys, while we are waiting for Kenneth to be loaded as co-host, on top of the screen, I also wrote, where has the market gone? I don't know if you guys are experiencing it. There might be some of you that are extremely busy. If you are extremely busy, consider yourself one of the lucky few. Most guys that I've been talking to have been complaining about how quiet the market is. That includes both commercial and residential. Feedback I got from industry. And when I say feedback I got from industry, what I'm referring to is discussions I have with guys. So I might have a telephonic conversation with one guy. In my general discussion, I would ask, how's your sector, how's your market doing? And the overall feedback I've been getting is that it is extremely quiet. For the month of March, there was a 30 to 40% drop in the commercial market. Think of the scale of what I'm saying, a 30 to 40% drop in the commercial market. Now, we know that the residential market is quiet because there's no load shedding. But for the commercial market to have a 30 to 40% drop, that is insane. What I do see is I see a lot of light being reflected at the moment. So if it looks weird, I'm happy to close the curtains in the office or in the studio where I'm presenting. You guys can just let me know whether you can see me properly. Kenneth, are you there?
I am indeed. Good morning.
Excellent. Excellent. Good morning, Kenneth. Thank you very much for joining us. Do you want to introduce yourself, like a 30-second introduction to the members? That would be great.
Okay. Good morning, everyone. My name is Kenneth. I work for a company called the Lightning Gurus. Lightning Gurus is a well-established lightning protection company in South Africa, which focuses mostly on solar lightning protection for solar installations. We've done about over 70 megawatts worth of lightning protection for solar projects in the CNI space. I also serve on the working groups of the SANS working group for lightning protection and SANS 10142 Part 1. I also work a fair amount with the ECA. I give quite a bit of training for with Taki Investment, which is also a training center for lightning protection. So I educate the market, being electrical wholesalers, electrical contractors, engineers, etc. And yes, been in the industry for 13 years now. So I've basically seen it all. That's all from my side as an introduction.
That's cool, Kenneth. Thank you very much. I don't think I shared with you the video that I took yesterday.
Is it about that ground mount, about the solar panel, that air termination rod sticking out? I did see a video.
Yeah, maybe I should.
Busy you speaking.
Maybe
I can show it as well.
Yeah, I was going to show it, but you're welcome to show it as well. Let's see.
Because I wasn't sure if I'm allowed to get it. So just
guys, if you are in the meeting and you are having issues with reception, don't worry about it. The session is being recorded. Mariusha is going to upload it to the AREP YouTube channel. And you guys are welcome to access it there.
Okay. Nancy,
if I can get here. Can everyone see my screen?
No, it's not that one.
Is it not this one? This one
No, it's not one of those. So
okay, then I'll wait for the new one.
Wait, there's no new one. No, man. It was just, we did an inspection yesterday.
Okay.
I think you guys should be able to see my screen.
Yes, we can.
And when I say inspection, maybe I shouldn't say it was not like a formal inspection kind of thing. It was just I was on a site with some other guys and I started looking around. And this is what I found. So I'm going to hit play quickly. So what was impressive is this was a really amazing installation. It is super neat. Everything lines up. It's beautifully done. So what I found interesting about this installation is that these guys have air termination rod scattered throughout the installation. If you look at where the air termination rod actually goes, it's just situated underneath the solar panel, and it's not connected to anything, not connected to anything else. And there's no visible bonding anywhere on the installation, except for on the trunking and the wireways. Kenneth, that was the video I was referring to.
Yeah, it's the same as the one I have, just maybe a bit extra.
Okay, sorry.
That's no problem.
When I saw the drawings, I thought, no, this is going to be a different.
No, the drawings, no. But it's fine. Let me quickly go and just open up my. So Yes. Would you
It's
like me
nice
to
to
start?
know. It's nice to know that you've already integrated that video into your training presentation. Wow, you are really.
Not really, but yeah. It's just something like that. Yeah. It's just see which screen. Okay, everyone can see there. Okay, can everyone see my screen?
Yes.
Okay, good. Okay, so I'm going to speak briefly. It's going to be a bit of a mix and match because I'll tell you what we find in the industry and why people install that way, or other companies that install it that way. So maybe I can start. The biggest problem at the moment is that the lightning protection is not really clearly defined for solar systems. So it's sort of, you know what, you need to adapt because each solar installation is different. Each EPC or solar installer installs differently. You also have to start facing the reality of the roof structure. I mean, we're getting huge problems on roofs that if you do it incorrectly, as you know, with, for example, a Nova Taxi roof, if you drill or anything on that roof, you void the warranty and it can cost you 4 million rand to replace the roof. So, you know what, a customer comes and says, put on an air termination rods, and most companies will say, okay, let's just do it. How quickly we're going to do it, how easy and how cost effective. So with that video, hypothetically, what happened is it's someone that went and installed the cheapest way. It was the only way to do it. So either they could not install it on the roof, as what I'll show you now, and they decided to put it below the panels. It's quite common in the industry that they do it that way. The problem is that you're basically exposing full lightning currents onto that solar panel. So if one of those panels burns out, it can burn your whole array to smithereens because it's not 50 hertz frequency, it's high voltage, high frequency lightning currents that comes down. So you need to dissipate as quick as possible. So the correct way that should have been done, that application, for example, is that on a rooftop steel, it's very difficult to install angle rods like what was done on that video, purely because the structure is only a bracket that you purchase from K2 or from Lumax that holds the solar structure in place or the solar panel in place. So you need to basically install a dedicated 1 meter air termination rod, which they should have done, which is separately. So if I'm going to show you an example, it will be something like this onto a steel roof. Yes, you can clamp it on to the steel roofs. You can drill it if it's an IBR roof, depending on your roof application. So that is what should have been done. But because this is more expensive, it's not as cost effective, many companies install below the panel. The problem you have with the panel, apart from that video, with having the angle rod underneath the solar panel, it's basically touching the solar panel. And as you see in the video or the image that I'm showing you here, you can see that there is a separation distance that has to be maintained from the solar panel. Shall lightning hit the rod, it's going to dissipate into the structure, not the solar panel. So that is the correct way to do it. And to determine this separation distance, there's a calculation in the standards. I'm not going to go into that, but there's a calculation that can calculate this. Alternatively, you can put in your standard air termination rods, which will basically give you separation distance. There's two types of distance. There's core shadow and a diffuse shadow. A core shadow, as you can see, is a dark shadow that will cause shading onto your solar panels. That's also a big problem we have in industry. And then alternatively, you want the diffuse shadow, which is like a light shadow on your solar panels. So that is what the idea is when you're installing lighting protection. To get this separation distance, there is a calculation that's worked out. So if you use a 10 millimeter rod, it needs to be 1 meter away from the solar panels. So
Kenneth,
what we find, yes,
sorry for interrupting you.
correct.
One of the guys are asking, Daniel wants to know whether you can just put your slide in presentation mode. So just hit the play button so that it
Okay, I can do that.
pops up your screen. We've
Is
got
that
quite
better?
we've got quite a lot of guys joining on their cell phones, so it makes the
Okay.
images extremely small. That's cool.
Okay.
Thanks. Sorry for interrupting you.
No, it's fine. Absolutely. So what we find, so there is no such thing as a perfect installation on a solar installation when it comes to lighting protection, because there's always challenges. So example, if you take on most sites, I mean, I'm talking about shopping centers, I'm talking about your big commercial projects. The big objective of EPC, a solar installer, is to try and see how many megawatts or kilowatts can I put onto this roof, and how much gaps can I take, or how much space can I take up on the roof. But what many of the EPCs is forgetting is, what about the lining protection? So now there's some cases which I've had where I have to be a meter away from the solar panel, and we can't do it. We can't be a meter away purely because the parapet, which is the side of the building, is 500 mil away. So now comes the question, how do you do it? And that is exactly also why many installers will opt to install, like the video, to put air termination rods below the panels. So that is a big challenge we have in the industry when it comes to lighting protection for rooftop now. So rooftop, most cases, depending on the roofs, it also becomes tricky because the brackets you get from Lumax, the brackets you get from K2 or any alternative company, has got anodizing a lot of the time, so there's no bonding. And the problem we face is SANS 10142 says that if you put anything on top of a roof that is a steel structure, shall be bonded. So now you go to site, you install your array of solar panels. Let me actually see if I've got another picture. Let's use this. So you install your array of solar panels on a steel roof, and you use a Lumax. I'm just going to use Lumax clamps. You use a Lumax clamp to fasten it. The problem is solar installers link each solar panel with 6 millimeters square or 4 millimeter, whatever the standard recommends you to do. And then you've got a cable running into your P9000, your cable tray, which goes down to an earth rod. And then, of course, it gets equipotentially bonded. But what we find is, because of the waterproofing on the roof, and because of the water or the anodizing on the clamps these days, because they're not really galvanized, the problem comes in, there's no continuity. So I can test between, let's say, this solar panel frame to that structure, and there'll be continuity, 100%, 0.2 ohms as per the standard. But if I take it from that Lumax clamp to the steel roof, 99% of the time, there's no continuity because of that anodizing. So now brings the question. The standard says it must be electrically bonded, your solar system. It must be equipotentially bonded, which means you need to connect to the electrical system. Your building needs to be basically connected to your electrical system, which shall be done by a registered person. So that has to be done. And what we're finding in 99% of the cases, the solar panels has got continuity, but the roof to the solar bracket has got no continuity.
Okay.
So that is what we're facing in industry at the moment, Carel, is that the roof and the bracket is where the big problem comes in. So normally what we do for IBR roofs, you can actually, I mean, we gone to such an extent now, when we test for our lighting protection systems on a job, we actually test the EPC solar installation as well, because then we fix it while we're there. So we make sure that we'll bond the solar panels as well to the roof so that it's done as per the standard.
Okay, cool. That's in the case where you guys do the so you guys not only supply, you also assist guys to fix the installations, and you can do some of the contracting. I'm just trying to get around the services you offer.
Yeah, so we do currently we do installations in that as well. We sort of moving away from it to start. So my big dream, which I've had, is that I want to enable other contractors to also do the work, or other companies to do their own installations, because it's not rocket science to install the lighting protection system. All that it takes is you need to have some understanding of the standards and you need to have some practical work done. So, Carel, so I'm sort of moving away from that. So what I do currently is I assist existing, like for example, that site that you got there. If I speak to the EPC or the contractor that did that, I will actually get the EPC to redo it and they can use their labor to fix that site up. So that's ideally what happens currently. On new jobs, we normally tackle new jobs, complete turnkey solution. But in that case, we'll actually assist where we can. That's just for now.
Kenneth, that's great. Can you stop sharing quickly?
Sure.
I see we've got 1 or 2 questions coming in, but before we look at the questions, so I am going to pin, I don't know whether it has value. Guys, if you can't see my camera, just pin the camera to the conversation, and then it opens up the image. So Kenneth, I don't know if you can see what's on my whiteboard.
Yep, I can see it. Yes.
So while you were talking, I quickly made up this drawing. This is what the video represented. So this black part over here shows us the solar module.
Okay. Do you have
The purple block over here is the mounting structure. The red over here was an insulating rubber in between the mounting structure and the IVR roof sheet. Now that is obviously the part that you were talking about that is going to create the fact that there's no continuity between these two metals, right?
Correct. Yes, absolutely.
The other thing you mentioned is if we have a lightning strike over here, there's absolutely nowhere for the surge to go because this is insulated from the roof. So where I'm going with this is you mentioned something that you call the separation distance. The separation distance got me thinking because you effectively get 2 types of lightning protection systems. You get an isolated one and you get a bonded one. The one where you have the separation distance, that's on the isolated one, isn't it? Did I lose you? Have I lost?
No, you did.
Okay.
On the isolated system, you need separation distance. But on a bonded system, you also need separation distance. It's both. Remember, we're working with a steel roof. If it was a concrete roof, it would be different.
Yes, thank you. Okay, so this is perfect. This is bringing us closer to where I was kind of heading with this conversation, because there are a couple of, I wouldn't want to call them issues, but with what they've done over here, they have actually forced the installation. So instead of planning the installation and planning it to be either that should be insulated or bonded. Is it isolated? Isolated. It's either isolated or bonded. The minute you've got a steel roof, you are forced to go with a bonded system because your solar system is supposed to intrinsically become part of the same continuity of the metal. Am I right?
Yeah, absolutely. Yes. Yes.
Okay. So now you are forced. So because they've put these air termination rods in, it means that they are expecting lightning.
Mhm.
And because they're expecting lightning, this forces them to put in type 1 and type 2 surge protection equipment.
Yes. Theoretical, yes. Yes. I'll get to
Okay.
that now.
Give me the practical side of the conversation.
So what we find at the moment, we're just talking about steel roofs now.
Yes.
And it's now been proved, we've proved it now over 70 megawatts of projects, that if you, the inverters come out standard with a type 2 surge arrestor.
Yes.
The standard, the lightning protection standards and SANS 10142 actually says if it's a lightning protection system installed and it is bonded, which means you bring in lightning currents into your system, you need to install a type 1, type 2 lightning arrestor. That's now the theoretical part. The practical part is it's not economically viable to install class 1 SPDs because you'll need to, for that inverter, if you've got 20 strings, you'll need to install 20 type 1, type 2s, at example, 2,000 Rand a pop. So now you're all of a sudden looking at a cost implication for something that might not be needed, because if you start going practically and you start thinking about it, that steel roof is connected to either rebar of that building or it's connected to I-beams. So you've got 100 different parts going down to ground. So by the
Correct.
time it gets to your inverter, the type 2 will be able to clamp that lightning voltage. Because why I say it will clamp it is because according to 60364, it's not the solar standard, it's a similar standard. Basically, what it pertains to is that a type 2 must still handle lightning currents as well. They call it partial lightning currents that it can handle. So that will be able to absorb that lightning current. That's now the practical part. And that's what we've done for 70 megawatts and had no problems.
But now what that means is that between the roof, so if I have my purlins, I'm just gonna, what do we call this, steel structure? I have my steel roof structure over there. This is now going to mean that you are going to have to ensure, let me just get a different color. Where did I go with the green? This is going to mean that you're going to have to ensure that that is continuous to that, is continuous to that, is continuous to whatever it is. If you have steel beams going down and they are bolted into concrete, concrete pillars or concrete foundations, this is going to give you a path, and you're allowed to use it according to the standard, but it's not going to help you if you just have one. So the idea would be to ensure when you do the installation that you have multiple paths going down to ground.
Correct, Carel. So if you start looking at lightning protection, the standard 6305 says that you shall have more than one down conductor. So a lot of what we find is a lot of EPCs or solar installers, they install an alternative supply, and that alternative supply, they push for 5 ohms, argument's sake, and they say we can use that for lightning protection as well. You can't use that for lightning protection because lightning protection is high frequency. So on a steel roof like this, you don't need to add, so maybe I can start here because you guys are going to ask the question, how do you know if it's continuous? There's normally a tester that we use that injects 10 amps into the building. So we can test the continuity of the roof sheeting to the building, to the electrical system. If that is 0.2 ohms, then you know that the down conductors is fine. Then you don't need to add any additional down conductors because it's already existing connected to the roof. As soon as that continuity is not there, then you have to start doing what Carel is saying by saying you've got to have down conductors that go to an earthing system.
Okay.
Does that make sense? So I'll show a picture just now. I've got it in my presentation. I'll show the difference.
Okay, that'll be pretty cool. Thank you very much.
Maybe-
Can we? Was there anything else? Can we quickly jump to the questions?
We can, and then I'll show that. It's fine because I see there's quite a bit.
Yeah.
Where do we start?
So Peter says, so you can use the roof itself for bonding, or do you still need to bond the air terminations with each other? And is it needed to run a down conductor to an earth spike? So Peter, I'm going to answer that, and then Kenneth can add to it as well. If you are expecting a direct lightning strike, you've got to ask yourself, is one earth spike with one down conductor going to catch whatever lightning strikes it and safely conduct that down to earth? This standard over here says no. It says if you're expecting a lightning strike, you have to have more than one down conductor. And if you're expecting a lightning strike, you can't go with a 6 millimeter or even maybe a 16 millimeter. You've got to size your cable according to what it is you're expecting to happen on site. Kenneth?
Yes. So that will be, to answer that, it's 50 mil square is normally what's needed for down conductors. But in this case, you are right. It's exactly what you explained. Yeah, it's right.
So
There's nothing.
I like the 50 millimeters squared because the 50 millimeters squared makes provision for mechanical as well as electrical stress.
Correct.
So you've got to be able to use a conductor that would be able to handle not only the electrical conductance, but the mechanical stress that the lightning is going to put on that conductor. And for that, the standard says minimum 50 millimeters, but it says 50 millimeters copper, aluminium, or steel.
Yes, correct. So normally with galvanized is 78 mil square, but for copper and aluminium, it's 50 mil square.
Yeah, that's beautiful because that now means that brings us back to this pillar over here, as well as the foundation and all the other little bits that goes along with it, to get your earthing system sorted. But that is something that you'd also be able to assist the guys with.
Yeah, once you do a test on, so what we found is most buildings, I would say 99% of buildings has got continuity on the roofing structure to the building. So that is already done in place. It's very few and far between that you get something that's not, or a roof that's not bonded.
And then we have Kevin. Kevin says, hi, Kevin. Kevin says, a vast number of installations from domestic commercial are overpopulated. Maintenance and access walkways are ignored in favor of filling up the roof to a point where first responders would not be able to even get onto the roof. The aspect of fire setbacks and walkway standards are far more critical for safety. This is a real safety concern. The industry fixation on the grid safety in relation to these real safety issues is misplaced. Fully installed systems are actually a risk to the end user and their buildings and first responders. Kevin, I'm going to definitely agree with you there, but I think from a so I'm not dodging or sidestepping the issue. What you are saying is correct. I think in terms of this discussion, so I'm happy to have a discussion on what you're mentioning there, but that would have to be in a different topic. So that would actually make for an interesting meeting. So maybe the next one or the one after that, we could talk about first responders and access on a solar installation. At the moment, I think everybody's placing a lot of emphasis on electrical safety and electrical standards. Electricians are not trained to do earthing. Electricians don't have earthing and lightning protection as part of the training. And I'm not talking about single phase testers, guys. I'm talking about the whole string. The whole range of them are not trained for earthing and surge protection on solar PV systems. So it's important to cover these topics. These guys, so Kevin, just about what you were talking about, these guys had walkways every second row. So they had two strings of panels next to one another, and they had a walkway. It was a narrow one. Now I know I think the standard requires, was it a meter or was it 600? I don't recall whether it was a meter or 600. So nowhere on the perimeters was there a meter gap. There was a big enough gap to be able to walk there and to walk there safely. And there were walkways in between the strings. So the systems are definitely installed better than what they were in 2016, 2017. The guys would just cover the roof. I don't know about the current average practice. George then says he had to jump off. Sorry, George, you can get the recording. Ntlantla says on concrete roof, I think it's separate. What method would be best to equipotential bond on a concrete roof? Kenneth, you want to get that? I think
Yes,
that brings
I can do that. Okay. So normally on a concrete roof, you don't install it the same way as what you do on a steel roof. The brackets and everything are different. So ideally what happens, it's actually the best scenario for a concrete roof to do an isolated system, which means that you're taking the lightning currents away from your solar panels. In saying that, you need that lighting, as soon as it takes it away from lightning currents from your solar panel, you need to dissipate it. So there's two options. Either you use dedicated down conductors is what they call. So that's the aluminium or copper that they run on the side of the building. Or alternatively, you can cut open, you can chip into the rebar, into the concrete, and connect it to the rebar, existing rebar structure. So those are the two options that you'll need to do for equipotential bonding, because when a building gets erected the first time, the building is already electrically bonded. So equipotential bonding is already done. It's literally taking your lighting protection and doing equipotentially bonding onto that. So you need to take your LPS and connect it with the building's earthing, or like I say, a rebar and earthing system. And then it will also be equipotentially bonded at the same time.
So what I've just drawn while you were busy chatting is I quickly drew a flat concrete roof. I've got the air termination on the parapet. The section over there is the separation distance. Separation distance. The difference over here is that your lightning protection goes down to the ground over there. It's bonded to your earth bar and your DB board, and this is bonded to the earth bar and the DB board. But this section over here ends up with type 2 then, if I remember correctly.
Inside your AC board, you're going to put in a type. Well, again, the standards, theoretical and practical again. Okay. Normally, type 1, you use always with the lighting protection being an isolated system or bonding system on the AC side. On the DC side, you can have type 2s on an isolated system because you're not exposed to any lightning currents.
Yes. Okay. Thank you very much. Okay, so that answers that question. I think it does.
Yep, I'll show pictures just now to explain it more picture driven for them, so they can
Ntlantla
understand.
wants to know whether copper bonding strip is allowed. Ntlantla, copper bonding strip would be allowed if you don't just use one bonding strip. So you'd have to use lots, because you're trying to get the square meterage or square millimeter of, or the amount of places where you can get that power to dissipate. You're trying to get more of those. So can the bonding strip work? Yeah, it can work. Is it ideal? Probably not. Also, for me, the interesting thing about copper bonding strip is aluminium. Aluminium doesn't like copper very much. So you shouldn't bond copper and aluminium directly to one another, because you're going to get bimetallic corrosion. Ruan says, we found that buildings are non-compliant in terms of lighting protection, bonding and earthing of their steel structures and roofing. That's quite true, especially if you're looking at the older buildings. Then Ruan says they expect you to do lighting protection, bonding and earthing only for the solar system. In my opinion, you can't do partial installations. The complete site needs to be compliant. When we advise clients on this, we always end up being more expensive than other installers. Kevin? Kenneth, sorry, I'm reading.
Yes. Yeah, I'm actually shocked, to be honest. Ruan, thank you very much. You actually probably below 5% of the people that actually take notes of exactly what you said now. I'll comment it. I'll try and make it as brief as possible. You're absolutely correct. It is partially done because a solar installer is only responsible for the solar panels. The building's lighting protection is purely on the onus of the end user. So I'm going to paint you a scenario. According to the building regulations, SANS 10400T, it clearly indicates if your building is in a lighting flash density greater than 3 or 7 strikes per square kilometer, that's your lighting flash density, you will need to do a risk assessment. Upon doing a risk assessment, there will be 100% chance of having lighting protection for the building that's needed, because you've got occupancy, which people inside the building, which can get electrocuted by lightning, which means that you need, it's called loss of life, which means that you'll need to install a lighting protection system. Now comes the problem. Most companies don't do that. The end user doesn't get the correct documentation. He doesn't go ahead and follow the standard, the building regulation, which is normative as well, by the way. Now they come, let's just say Lighting Gurus, my company, example, goes and installs solar panels on the roof. Now all of a sudden, it takes up 80% of the building. Ruan, now the problem is, what is your responsibility and what is the end user's responsibility? And this can be costly. And I understand totally why you're losing business, because you're taking the end user's, how can I say, his problems as well onto you, where your opposition only cares about solar and they'll only protect against solar. So it is a big common issue inside the industry, because the end user will say, I want my building protected, but at the same time, I want my solar system also. But Ruan will turn around and say, but I'm not liable for the building. I'm only liable for the solar system. Then you go and you help the customer, you quote, alternative quotes come in, and I can guarantee you, Ruan, you'll lose 99% of the time. You will, because the end user does not understand the concept between the two. In saying that, you can only have one risk assessment. So if a risk assessment has been done to the building and you add solar panels or solar installation does not change the characteristics of the existing lighting protection system. So if you've already got an existing system you can use that and basically protect your solar system with the same, they call it the lightning protection level that you'll need to use to be able to protect your solar system. That again is in a perfect world, because over time, like Carel said, older buildings, they lose the documentation. So now the end user has to protect his building and his solar system. So now you have to do a risk assessment. So now for Ruan, it's going to cost X amount. And your position's only going to say, okay, let's go for the solar system, and it's going to be Y. So Ruan, you're absolutely right with what you're saying. It's a big problem in the industry currently.
Kenneth, just to add to what you just said, a couple of years ago, so when I say a couple of years ago, what are we talking? 15 years ago. And maybe those large companies doing earthing are still around, but there are obviously a lot more guys that have been introduced into the market. But a couple of years ago, let's make it 15 years, there were only 3 companies that were doing quotes. And if you had a look at what they quoted, they would shave their pricing to near cost price so that they win the project. And then when they go to do the installation, instead of using the copper rods, they would end up just using steel. So they would come in low and then change the material from what they originally quoted. So they would quote one to put their price on par with what other guys are quoting, and then they would install inferior equipment. And if you look at the likelihood of someone coming to test your earthing installation, no one's going to dig a hole to take out an earth spike to see whether it was the right quality. So in industry, we are faced with a lot of different aspects, especially for guys who actually care. Guys who care are probably not going to get the job.
Yeah, absolutely. That is correct.
Thanks for that, Kenneth. Moving on, Daniel says 50 millimeter square copper or aluminium, considering the current rating. Yeah, Daniel, yes and no. So the only time that you would use the 50 mil would be when you'd expect direct lightning. And for the 50 mil, you are actually using 50 mil for its mechanical strength and not for its electrical conductivity. So yeah, it kind of becomes, I think what you are referring to is where the blur in the industry comes in, because you've got to go and have a look, but how many down conductors do you need? What is the Ka of the lightning strike you're expecting? What is the material and mechanical and electrical conductive properties of the material that you're using? So it kind of starts becoming difficult as far as calculations are concerned, but I'm sure you guys would be able to give Kenneth a call and he'd be able to chat you through that part of it.
Perfect, no problem.
Kenneth, what do you know about, Veli wants to know about lightning. What's that? Lightning and surge protection are the same in this instance. Yes.
Where we now?
Well, technically, yes. If you're expecting just a normal surge, you'd go with type 2. If you're expecting direct lightning strike, you would add type 1. So really, yes and no, as Kenneth would say, theoretically and technically, that might be different.
So I can maybe clarify that. So
Okay.
the surge protection, a surge protector can only handle surge. It's a waveform that is 8x20, and lightning is 10x350. So lightning and surge is totally different type of beasts, let me call it that. So it's not the same. However, you get surge protection devices which can only handle the surge, and you get a lightning arrestor which can handle the lighting current. So I always refer it to a Chihuahua or a small Yorkie, that is a surge protector, and your pit bull and your Rottweilers, that is your lighting that it can actually handle. That's to put it in a bit of simpler perspective. So there are different dogs, totally different, but you can get one that can take both.
Okay, that's great. Thanks, Kenneth. Michael says, so you will need a COC again for LPS. I think it's Michael I was thinking of. Kenneth, what do you know about the COCs for lightning protection systems? I don't think they are required yet by the insurance industry. What's the consent?
Yeah, they are.
Are
They
they?
are actually by insurance. Yeah, insurance companies is asking more and more solar EPCs. They're asking now the solar companies, please, to provide it. So understand this, Michael. There is only one COC, and that is the electrical COC. Before, I get plenty of calls from electrical contractors. A COC, there's one COC, it's electrical COC, and I'm sure there's now solar test reports, which goes with the solar panels and that, or solar installation, which goes with the COC. Lighting protection is purely just a test report. It is it's an attachment. At this moment, and I'm going to be brutally honest, and I'm sure I might shoot myself in the foot now, but a lighting protection ISR means actually nothing, except for that it's got some ownership for the person that's installing it, so that you've got his contact details. So if something happens, you can take him on about it. In the future, we are looking at trying to work with Department of Labor. There's different ways we're doing it, that it will basically form part of a COC, which will become legislative, but be 2-3 years away from that. So I hope that answers your question. It's called the Installation Safety Report. Every company should do it. That does the lighting protection installation. What we do find is you get a Bucky Brigade guy that will type out a letter with his company logo on, saying, I hereby swear that the solar panel or this lighting protection is compliant. And because the end user doesn't know any better, or an insurance company doesn't know better, they will actually accept it. To get that document, it's in the standard SANS 10313, where you'll get the ISR, Installation Safety Report, inside that standard that you need to use.
Okay, that's cool. Kenneth, I just want to clarify that quickly. So you get plumbing COCs, you get glass COCs, you get an electrical COC. I think what Michael was referring to here was a COC specific for the lightning protection system. So you have to have a COC for the electrical side of a solar system. That is that's not what's the word? There's no discussion about it. You've got to have a COC. But what you were saying was that there's no specific certificate of compliance for the lightning protection system itself, but you have a, what did you call it, an ISR?
You can just call it a test report. It's like in electrical, they use Annex H, which is like a test report. With lighting, it's just, to clarify it for many people, we call it the lightning COC, but it's not really a COC because it's not with the OSH Act and it's not with the Department of Labor. So it actually means nothing, there's no legal terms with it. But it's a test report that you added onto with the electrical COC. So it has to be connected to each other.
Okay, that's pretty cool. Thank you very much. Guys, we have run out of time. I'm going to quickly do the last couple of questions. Ralph says, thanks for educational session. What's the minimum required for a home system with regards to lightning protection and grounding the PV array structure? Ralph, quickly, if you are expecting lightning, then according to that 62305, you have to have at least 2 down conductors, one on this side of the house and one on the other side of the house. That is not how it's being done in South Africa at the moment, because that is not the way the social media WhatsApp groups are busy discussing this. So if you look at the social media WhatsApp groups, As long as you have a 16 millimeter squared cable and an earth spike, you're sorted. As far as how it works in practice, that is not going to be adequate if you are expecting a direct lightning strike. Kenneth, do you have anything to add there?
No, not really. Not really anything there.
Are you playing it safe?
Yeah,
Okay.
yeah. Well, it's not really safe. It's an open-ended question, because again, it's so firstly for a residential application, and yeah, I'm going to get crucified for this, but I can tell you with all the research that we've actually done, 99% of the time you won't need external lighting protection on a building. It's only normally the wealthy people that want to install it, the wealthy owners, and owners that want to protect their assets. The reason why, the big reason is it's got to do with the size of the house. So if you stay in a palace, then most likely you'll need lighting protection. For your normal middle class to your upper class, it's really not needed because your catchment area, so the size of your house, you've got neighbors as well. So the likelihood again is, what is the chances of heating your building? So now you're going to spend 80,000 Rand to protect your house for something that might strike 1 in 60 years. So that's why I say it's an open-ended question. It's a difficult one to answer, but I can tell you, I get lots of requests for it, but I just say, surge protection, bonding, make sure your solar is protected that way, and everything's fine. I wouldn't install external lighting protection for a residential, but that's just my opinion.
Yeah, thank you very much. Thanks for that. So Ralph is in charge of the in-phase microinverter range of products in South Africa, and I think his question had to do with that, related to the products that they distribute. Last couple of questions. Sean says, what's the best way to bond the conductor to a solar module? Steer clear of bimetallic corrosion. Any guys, I'm going to have to make Sean's question the last question, and then I'm going to have to ask you guys to either contact Kenneth directly or to send us an email and we can forward it through to Kenneth. Kenneth, bimetallic lugs.
Correct. So very good question, Sean. So the practical side, I'm going to say again, the practical side we normally go for tin lugs because we find that the tin lugs don't give us any corrosion, so we don't get any rust. However, on lighting protection systems, we use a stainless steel clamp. So you'll see many of the manufacturers also supply stainless steel clamps, and that is what we use if we use two different metals. You can use bimetallic, but bimetallic is more European. With bimetallic, where you've got the copper on the one side and you've got aluminium or galvanized on the other side. In South Africa, we just use stainless steel. So that's the only way to connect it. But you're asking, how do you connect it to the solar panels? I'm taking it as an alternative supply. I just make sure that I use stainless steel. I don't use, I'll use aluminium cable for my alternative supply, believe it or not. And because it looks aesthetically, it looks good. And then I just connect it to the solar, well, not really the solar structure, but the frame. I use a stainless steel clamp to prevent galvanic corrosion or any corrosion for that matter.
Excellent. Kenneth, thank you very much. We will send your contact details. Alternatively, if you want to pop your contact details in the chat box quickly, you're welcome to do so. We have to conclude this session. It's 12:15, so we're about 15 minutes over schedule. I would like to thank everybody for attending today's session. Sean, you had a question about level 3. I will get that sorted for you. I didn't know that it wasn't on there. We've got guys that organize the website for us. So we will make a note of it and make sure that it's addressed. Guys, thank you very much for staying logged in. For the guys that have logged off, this is going to be available as a recorded version. Kenneth, thank you so much for your time. We really appreciate your input.
Thank you very much. I appreciate it. I appreciate the time. It's always nice to educate people.
Thanks, guys. Thanks, Kenneth.